Hello everyone, welcome to this lecture series on thermodynamics. In this series, let's go through the basic concepts of heat, work and internal energy. In the previous series, we have already discussed heat. For the sake of continuation, let's see what exactly is heat. Heat is a form of energy in transit. It is generally denoted by Q. SI unit of heat is joule. We know that heat always flows from a body of high temperature to a body of low temperature, that is from a hot body to cold body. This process of heat transfer takes place until the temperature of two bodies become equal. Coming to the concept of work. When a force acts on a system such that it produces displacement in the system, then work is said to be done. Suppose, if we take a system whose initial position is A, and if we apply a force F such that it causes a displacement such that the initial position changes to the final position B, the displacement is S. So when a force is applied such that it causes some displacement S, then we can say the work is said to be done. Now, in the physics concept of work, it can be defined as the work done is equal to force into distance moved. Mathematically, this can be written as W is equal to F into S. The SI unit of work is joule. Since we are using work in thermodynamics, let's see according to thermodynamics. So according to thermodynamics, the work done on a system is the total quantity of energy of the system and its surroundings exchange within themselves. That is, here the total quantity of energy refers to the system and its surroundings exchange within themselves. So the work is again of two types, external work and internal work. External work. If a system as a whole exerts a force on its surroundings and a displacement occurs, then the work is called external work. See, this is the system and these are all the surroundings. If a system as a whole exerts a force on the surroundings, then we can say the external work is to be done. Again, if the force is exerted on the system from the surroundings, then also we can say the work done to be external work. So to put it together, if a system exerts a force on the surroundings or if the surroundings exert a force on the system, in both the cases, we can say the work done to be external work. For example, let us take a cylinder which is fitted with a frictionless piston and it is filled with a gas at uniform pressure. When this gas is allowed to expand, then while expanding, it pushes the piston out and thus external work on its surroundings. Next comes the internal work. If a part of the system exerts a force on the another part of the system and a displacement occurs, then the work done is said to be internal work. For example, work done by the gas during the expansion against the internal molecular forces of attraction is known as internal work. Then coming to the concept of sign convention. A sign convention is required for heat and energy transfers and the classical sign convention is selected for these nodes. We know that the sign conventions are important because we have to follow the certain sign conventions while applying to the some laws of thermodynamics. According to classical sign convention, heat transfer to a system and work done by a system are taken as positive. And heat transfer from a system and work done on the system are taken to be negative. To be more clear, we can just go through this. Heat absorbed by the system is taken as positive. Heat evolved by the system is taken as negative. While the work done by the system is taken as positive, work done on the system is considered as negative. Now, sometimes most of the students will be at ambiguity or confusion that in physics textbooks, the work done by the system is taken as positive, while in chemistry textbooks, we can see the work done is taken on the system as positive. The reason being the sign convention is different in both the cases. This brings some confusion. The reason for this is in physics class, we write the first law of thermodynamics as du is equal to dq minus dw, while in physical chemistry class, we write the same law as du is equal to dq plus dw. So as we are dealing thermodynamics in physics, for this we will take the work done by the system as positive and work done on the system as negative. Next comes the important topic, which is known as the internal energy. We know that every system is associated with a definite amount of energy, which is known as the internal energy. It is generally denoted by E or U. It is the energy that a system stores within itself. Of course, it is not apparently shown by the system. It is stored within the system. This energy stands for the total energy of the system. So what is internal energy? Internal energy is the stored energy which is not apparently shown by the system, but which is stored within the system. It depends on various factors such as temperature, pressure, and chemical nature of the substance. Of course, it's not possible to measure the internal energy of any system. We can only calculate the change in internal energy of the system. This internal energy can be well explained with the help of this simple diagram. We know that matter consists of a large number of molecules. According to kinetic theory of gases, all these molecules will be in a state of constant random motion. Due to motion, every individual molecule possesses a certain type of energy which is known as the kinetic energy. So this kinetic energy is termed as the internal kinetic energy of that particular molecule. So since the matter contains a large number of molecules, or a system contains a large number of molecules, the internal kinetic energy possessed by all the individual molecules put together constitutes the total internal kinetic energy of the system. Similarly, there will be internal molecular forces of attraction within the molecules. Due to intermolecular forces of attraction, the molecules possess certain type of energy which is known as potential energy, and it is termed as internal potential energy of that particular molecule. So, all the molecules will be possessing internal potential energy. The sum of all internal potential energies of all the individual molecules put together will constitute the total potential energy of that system. Now, this total internal kinetic energy and the total internal potential energy put together will constitute the internal energy of the system. So, the internal energy of a substance is nothing but the sum of kinetic energy of all the molecules and the sum of the potential energy of all the particles. Now, to sum up, we can say that the internal energy is the sum of kinetic and potential energy which is present in the system. It is a state function of the system. Its value depends on the state of the system. The change in internal energy is generally denoted by delta U is equal to U2 minus U1, where U1 represents the internal energy of the system in the initial state. U2 represents the internal energy of the system in the final state. It is the extensive property and it has the same units as that of work and energy. So internal energy mainly depends on the state of a system, but it does not depend upon the path which it has followed. So hope you have followed the basic concepts of work, heat and internal energy in this series and feel it worth watching.